So welcome to our second semester of physical science. This semester we're really going to be focusing on energy and the different forms that we can see and use in everyday life. So we need to have a little bit of an introduction to that. I've decided to go ahead and split your notes up into two separate videos because I'm going to walk you through the process of doing some word problems, and I know it's going to make it a little longer, and I didn't want just one video to slow down your computer as you're trying to load it. So hopefully with it broken down we can make it a little more manageable. So to start out, we just have to ask ourselves the question, what is energy? And so we can define that word as the ability to do work. And work is something else we'll talk about later on in this 9 weeks, and basically it's just the ability to move an object over a certain distance by applying a force on it. So the ability to do any of that is known as energy. So the two main forms we're talking about in our notes today are potential and kinetic energy. So this first video will be focusing on the first one here in the list. So potential energy is stored energy, and it's based on the position or chemical composition of the object. So basically like where it's located or what it's made up of. The amount of potential energy that is associated with the object will depend on its position. There are two types of potential energy. The first one is called elastic. So when you hear that word, you probably think of like an elastic waistband in a pair of pants or a rubber band. Those things can be stretched. Springs are also a good example. These can be compressed, so that means to be pushed together. The other type of potential energy is gravitational potential energy. So as you can imagine, that deals with gravity. That's the root word of that longer one, and that is dealing with the height. So if we think of something falling, then at the top of its fall it has potential energy. So let's think of some examples that we can apply to everyday life. Say you open up your locker and you've got a bunch of stuff crammed on that top shelf, and as soon as you open your locker, it all falls down in your face. Well, when it's sitting there in your locker and it's closed, and just as you open it, it has that potential to fall. So that would be an example of potential energy. So something may be sitting on the edge of a shelf, or a ball sitting on the floor. It has the potential to move. It's most likely not going to move on its own until someone kicks it, or maybe there's an earthquake or something drastic like that. But basically potential energy usually involves something that's not in motion. So that's a way we can remember how to come up with examples. So there are some ways that we can calculate how much potential energy an object has as long as we know some information about it. So potential energy is equal to the weight of an object times the height of an object. And we've discussed before at the beginning of this year that weight and mass are actually not the same thing. Weight is actually mass times the gravity of like the force being pulled on it. So in this case we're talking about Earth's gravity. And we're actually being pulled down toward the center of the Earth at a constant rate of 9.8 meters per second squared. That is an acceleration number. So that means like if you fall out of a plane and you don't have a parachute, that's how quickly you're going to be accelerating towards the Earth if you didn't have any wind resistance at all. So again, the weight is dealing with gravity as well as the mass, and the unit we use is called the Newton meter, or we just shorten that to the joule. This is what we're mostly going to be using in class when we do calculations. So here's our first practice problem. It says Richard wants to know how much potential energy his cat has when it climbs to the top of the tree near his house. The tree is 15 meters high, and the cat has a mass of 5 kilograms. How much potential energy does the cat have? First thing we want to do anytime we have a word problem is write out our equation or formula we can use. And so right now we're going to use weight times height. We're given height, which is 15 meters, but it tells us mass is 5 kilograms. We can't plug in mass for weight. Those are not the same thing. So we need to go over here and figure out the weight first before we can plug that number in. So I've got my weight equal to the mass times gravity. My mass is 5 and my gravity is 9.8 because that cat is going to be falling towards Earth. And so when we multiply 9.8, I have to do it on my phone real quick. It's going to be 49, and we need to use a capital N for newtons because newtons is the force, and weight is a type of force. So now we can plug that into this equation here. We've got potential energy. I've got 49 newtons. I'm multiplying that by 15. So when I plug those numbers into my calculator, I'm just going to do simple multiplication. That potential energy is 735 joules of energy. And that energy is going to be used when that cat starts to fall, or if it decides to jump, because we all know cats always land on their feet and they're just fine. Hopefully it wouldn't be too high of a jump for him. All right, we have one more. A hiker climbs up 40 meters up a hill, and he weighs 680 newtons. So I've got my height, I've got my weight. This is a really easy one to plug in. We want to know his gravitational potential energy at the top of the hill. So if he were to fall down the hill, then here's how much energy would be turned into kinetic energy. We've got weight is 680. My height is 40. Plug that into my phone. And that gives me 27,200 joules. Okay, so if you look at the next video, we'll talk about kinetic energy and get some practice doing some of those problems, and you'll be good to go for class tomorrow.